Hello everyone. Hi, this is Karthikeyan from TC Madurai. And now we are going to see about the most important package that is in the Python, which is used for many purposes, which we are going to see now. So we are going to see about the package NumPy, which is a important package in Python. So now the key topics which we will be covering in this session are: we will see about NumPy and the need of NumPy, the advantages of using NumPy over other packages, and what if NumPy was not invented, and we will be we will be if NumPy was not invented, and uses of NumPy in day-to-day programming, and why do we need to study NumPy? So if we are sure that we need to study NumPy, then where and what to learn in that NumPy, and we will wind off with some sample codes. Okay. NumPy. Actually, I was from start I was telling about NumPy. But what is it actually? Okay. Now let's see. NumPy. It is the fundamental package needed for scientific computing with Python. Initially, Python came up with just a list. List is similar to arrays which we use in C and Fortran in C++ in other languages. So in Python, they haven't included array concept. So initially they just included list instead of arrays. So list is just like our similar array. Sorry. List is also like an array, but it is expandable. Just like we can expand it or shrink it. We can reduce the size. We can increase the size. So it is also an advantage of list over NumPy. Sorry, array. But while implementing those in real-time programming like machine learning and data science, we have huge amount of data which are needed to be manipulated. So in those times, we can't that lists are not efficient. So they introduced the concept of arrays into Python. So they just wrote. So thus NumPy introduced the concept of array inside the Python. So they wrote the whole codings and the programs for arrays in C and Fortran, and they included those packages inside Python. Thus we have the Python package NumPy, which gives us the power of array. So coming back to the NumPy, it is the fundamental and the most important package which are needed for the scientific computing with Python. With while talking about the normal computing, we may not get to know the real value of array, but while computing on scientific values and on huge amount of data, we are really in need of arrays. So thus NumPy includes that level library which are written in C and Fortran, and it is used for high-level computation, high-level mathematical function which are used in data science. So what is the advantage of using it? Actually, I was saying it all about, but why we need NumPy? Why we need array? Just we need actually the prior thing which was list. It was like it took huge amount of space, and it actually took large amount of time for compiling and run, actually for interpreting. So thus we needed to reduce the time complexity involved in the computation. Thus we included arrays. So to this NumPy overcame the problem of running slower algorithms. Actually, the introduction of NumPy actually reduced the time complexity, and then any algorithms can be expressed as a function on arrays. So for example, if we have an array and we need to apply some function on all the elements of array, we can do it. Thus NumPy has many inbuilt functions which lets us to have numerous functions to be implemented on those elements. Okay, actually I was telling about NumPy and what is it comprised of. What is inside NumPy? The first and foremost thing, it has a powerful n-dimensional array object. So while talking about object, we can thus include the package of NumPy, and we can call those packages, and using those NumPy packages, we can manipulate any number of n number of dimensional arrays. So thus, it comprises of a powerful n dimensional array object, and it itself has basic linear algebra functions which can be implemented on those elements of arrays. And while implementing linear algebra functions, Fourier transforms, all these stuffs are really very complex, even with the hands. But while implementing those on each and individual element, just imagine how much big a code will be. So thus, the package comprises of all the scores which are needed to be included, so that just we are capable of using it very easily. So it comprises of all the basic functions of linear algebra and basic transformations, Fourier transformations, and many random number capabilities. And it also allows us to integrate the C code or C++ code or Fortran code. Why do we need it? Actually, okay, all the advantages of NumPy, let it be. But why do we really need it? Actually, it is the first and foremost step of data science. Nowadays, the whole crowd of world has turned towards data science. Ask anyone, all they all say that they want to achieve something in data science, something in machine learning, something in deep learning. So, what is the basic? So, while seeing towards data science, the first and foremost step would be learning NumPy. Is it so important? Yes, it is. Almost all, almost not just at most, not just all the packages, but almost most of the important packages such as SciPy, that is scientific Python, and Matplotlib, which is used to plot the results which we get for the data we have mined so far in the program, and scikit-learn, etc. We can actually list these. It is just example. We can also list most of many packages like TensorFlow, which uses NumPy as basic. So most of the packages, they rely on NumPy to achieve their basic functions. So it is really important to know NumPy so that we can achieve something in data science. So the first and foremost step for us, if we need to achieve something in data science, it would be I can tell you surely that NumPy is the first and foremost thing you must learn. Okay, what are the things with NumPy that are really cool? That what are the advantages which we have in NumPy? Actually, I told you Python just gave the real Python package, which was coming with the Python, just had lists, but we needed arrays. So what are the advantages of array over list? Actually, NumPy, what does, it gives array data structure. So using array, what are the advantages we have? It is actually more compact. While talking about, I'm not just talking about some 6x6 or 10x10, just not like that. I'm talking about huge amount of data, because in data science we must handle huge amount of data. So while talking about so much of data, it becomes more compact for using arrays over lists. At the same time, accessing the elements in list is somewhat tedious than in array. So using array, we can easily access and read elements from an array, and we can also write elements. And it is more really convenient to use. Well, while comparing, actually I have some sample codes at the end of this session. And while comparing the manipulations we can do on lists, we have much more things which we can do with NumPy on an array. And of course, it is more efficient. It is the most and foremost thing we must do while programming. Whoever we show the code, they'll first ask how efficient is this? How reliable is this? How efficient is this? So the first thing we must need is to make our program very efficient. So arrays are very efficient than this. Okay, imagine what if NumPy was not invented. For example, as you can see, what if Spanner snapped the finger and NumPy was vanished? Let's see. What if no NumPy? If there was no NumPy, the matrix and multidimensional array manipulations would be a daydream. Yes, of course. Actually, we are handling, for example, think of a two-dimensional array of 2 cross 2. Two dimensions arrays. You can easily multiply them or you can easily add them. But think of 3 cross 3. Even in 2D arrays, while the dimension of the array goes on increasing, the manipulations and the operations that can be done on the elements becomes tedious. But while talking about multi-dimensional, for example, 4 cross 4, 4-dimensional, 3-dimensional arrays, it is out of our imagination. It is hard to imagine itself. So while talking about such amount of array data, we need something to hold and we need some tool to use on it very efficiently. That tool is NumPy. So without NumPy, all matrix and multi-dimensional array manipulations would be still a daydream. And next, performing calculations with large data, I mean, I'm talking about huge data, would have been very costlier, both in terms of time and space. So thus, without NumPy, our program would be still consume lots and lots of time and space while running. And for example, just I quoted a single area of machine learning. All may have some basic knowledge about computer vision. In that computer vision, the basic thing is image. Even for videos, it is just a sequence of images. So this image we convert it into a 3-dimensional array which consists of red, green, and blue. Actually, our color coding system is RGB. So thus image must be pre-processed for handling some for using something on it. So computer doesn't know that image is like this. So we must convert it into binary code. So while converting, we use arrays. So while using images, we just convert it into 3-dimensional array. So thus there comes our NumPy. So there, even in computer vision, we are using NumPy to make it easy. So without NumPy, even the area of computer vision would be in their stone ages. So uses, as I have said earlier, size. NumPy data structures take up less space compared to other data structures. Performance. While coming to the performance, they have a need for speed. Actually, NumPy includes lots and lots of functions which are very optimized, and they actually reduce the running time of the program and are faster than lists, absolutely. And while talking about the functionality, NumPy have very optimized functions such as linear algebra operations built in. So we don't need to hard code it. Already they have lots and lots of functions which are pre-built within itself. So we just need to identify them and we just need to call them. That's it. So that it becomes handy to use NumPy. To need. Why do we need NumPy? NumPy is the most and one of the most popular machine learning libraries in Python. We may not just simply learn NumPy just because all are telling that it is important. But first we must know what is inside, and then we must learn how to make it useful for our own purpose. So NumPy is the most popular learning library in Python. Actually, there is a survey which tells about top 10 important libraries which are used in Python for machine learning. Actually, NumPy is the third top third library in that survey. Actually, all know the powerful open source API TensorFlow, which was released by Google. It uses NumPy for its basic operations. Actually, TensorFlow it works on tensors, that is multi-dimensional vectors, and it manipulates it. So while manipulating those vectors as tensors, it uses NumPy as basis. So wherever you go in machine learning, all the packages which we are using, they have something they base on NumPy. So NumPy acts as a dependency package for all other packages in machine learning using Python. And one of the most important uses, array interface is the most important feature. Thus, the replacement of lists over replacement of lists with array is the most important feature. Thus, we are using Python farly than Java or any other language for machine learning. And while talking about its real-time uses, it can be utilized for expressing images, sound waves, and other binary raw streams as an array of real numbers in n dimensions. Just imagine how tedious it would be to imagine a image with each color separated in its own form, red, green, and blue. But just imagine as a three-dimensional array. It would be very, very easy for us to imagine, and we have to imagine in an array. So thus, the implementation of n-dimensional array became very, very popular thing. That's why NumPy is very basic thing and it's very popular among the data scientists. And where to learn? Actually, I have told all this time that we need to learn, we need to learn NumPy. But where to learn? Actually, I have included so many links. It should be very useful for our learning purpose in this slide. So in the first link, I have told from Python to NumPy. Actually, it was written by Nicholas Thiagarajar. He wrote a whole book just to tell the importance of NumPy. So you can go and visit that book. It is actually open source. He made the book open source so that all may get used to it, so that all can download it and can read it. And these are the, in my knowledge, I have seen it. These two tutorials are really very most, they really explain things very easily regarding the NumPy. So these two tutorials are very, very easy and they are very important. So you can go and check it. And there are 101 exercises on NumPy. This website, when you click on this link, you will be linked to a website which gives you 101 exercises which you can work with NumPy. So while practicing, you get used to it very, very easily. And this is the official website of NumPy, numpy.org. It was with made by the developers of NumPy, and that's a page for official documentation. So whenever you don't know something on NumPy, you can go and check it on the official documentation. Actually, there is another one more most important thing. Why all took the path of NumPy? Because it has so many community of developers. So the most important and most promising thing is when you don't know something about NumPy. Actually, for example, if I don't know something about NumPy, there is really a community of developers all over the world who are working on NumPy. So if I don't know something, I can really reach out to them, and easily I can reach out to them using many resources so that they may help on it. So it is one of the most important feature of NumPy. Okay, how to start? Start with simple and easy matrix and vector operations. Just start with forming an matrix, forming an array with lists, and just manipulate it, just add it or subtract it or do some multiplications, apply some mathematical functions over it, and perform matrix operations. Just as I said, addition, subtraction, multiplication. Do a transpose of a matrix, dot products, not just two-dimensional matrix. You can do up to any number of dimensional matrix using NumPy. So get used to the basic functions and then start doing simple projects. Like do something with NumPy so that you are focused to a simple thing. Actually, our humans, it is a natural tendency to lose interest on something which we take with full interest. So to maintain that interest in the field of NumPy, you must really need to do some project so that you keep yourself busy on NumPy. And always look for an available module. Don't always hard code it, because NumPy consists of large amount of inbuilt functions that can be implemented and used over the elements. So just look for your purpose, look for the available model which will be meeting your purpose. And don't forget, NumPy, using only NumPy, you can't achieve anything. But NumPy is the basic thing. So try to include all other packages which will be useful for your simple project. And examples, yes, we have reached our last thing in our session, and there are few examples that are very, very easily. Many may have many knowledge over NumPy. Just I have told something which I would love to share. Just I have included few examples over NumPy. The first thing, I have already told you that NumPy, the most important feature is it introduced the array data structure in Python. So starting with the array, how can we use it? So just we can use, first we need to import the package. So just import the NumPy as NP. It is just nothing but you can use any variable for importing it, but while others see your code, it must be readable. Because if, for example, if I am importing NumPy as Karthi, no one, for example, when in the middle of a code, no one will know Karthi. If I just write Karthi dot array, they don't know what I have used. So while this they have globalized the NP for NumPy. So while using it, you can make your code very readable. So this code just uh, it just it is just making an array out of list. So here they have included two lists, and they have mentioned the data type as np.int, but it is not mandatory to mention the data type. You can just make an array of list. So here the my array variable holds the list, and it makes it as array. So while printing the my array, what would be the solution? Can you imagine? Yes, it is. The output will be in form of matrix. That is array. It is two-dimensional. So what are the universal functions? For example, there are so many inbuilt functions that are available in NumPy, and one of those functions are linspace. It just it separates the two regions or two boundaries you give into as many number possible. So here, so the linspace syntax will be the starting value, the end value, and the in subinterval value. So this thing divides these two divides this and this range into 100 times. So while running this code, A will have 100 separated values, equally separated values. So the linspace just creates a sequence of evenly spaced values within a defined interval. So when you give an interval, it will just separate those interval into equally spaced sequences. And you can apply any functions, like just see sine function. It is a mathematical function. So when you apply over an array, it will be applied to each and every element in that array. Similarly, cost. While talking about linear algebra, many would say that you need to study algebra, you need to study vector algebra, linear algebra, everything for machine learning. So how we are going to apply it in the path of data science or machine learning? Through NumPy. So you have various built-in functions which are used to implement the linear algebra functions or mathematical functions. Here, for example, see, you can just transpose a matrix within a single code. You can do an inverse. So you, for example, imagine the process of taking an inverse in an array. You just need to find the determinant values, and you have to form a co-matrix, a matrix from a covariant values. Then you must do the transpose, but sorry, you must do the inverse. But within a single line, you just found out the inverse of that matrix. And thank you. Actually, all it covered mostly it covered the importance and the need of NumPy. So you can go and refer those resources which will be teaching you the real NumPy. And thank you so much for hearing this session. Thank you so much.